Hi there, welcome to Arithmetic series. Let's get started. Okay, so here's lesson 1.2 on arithmetic series, the sum of arithmetic sequences. So a series is not just a sequence of numbers, but where we add up all of those numbers in a row. Okay, so we'll start off with a little bit of a story here, and that is the story of Gauss. So Gauss is a little child, was asked to add up the numbers from 1 to 100. In fact, his teacher was asked to add this up. Now, some say that this was as a punishment because it was just such a difficult thing to ask a kid to do, to sit there and add all the numbers from 1 to 100. And, you know, it was error prone. They were bound to make some errors. And in fact, all his classmates made errors. But Gauss was able to add it up. And he added it up in, a few seconds and wrote down his final answer, much to the shock of his teacher, at 5,050. And he was right. So how did he do it? Okay, well, we need to think a little bit about this. Okay, let's kind of zoom in and give ourselves some space. Well, if I think about the numbers 1 through 100, I could kind of reorder them and just sort of think about the extreme end of things. 1 and 100. Okay. What if I just added 1 and 100 together? What would I get? 1 plus 100. Well, that gives me 101, right? Okay. Alternatively, I could add up 2 and 99. Well, what does that give me? So 2 plus 99. That also gives me 101. Okay, that's interesting. What about the next numbers in? Well, 3 and 98. Could add those together, 3 plus 98. That pair of numbers also gives me 101. Wait a minute. In fact, if I keep going with this, 97 and 4 is 101, and 96 and 5 is 101, and so on and so on and so on. Each time I add a new pair of numbers together, I get 101. And just like what I got with the first pair of numbers. So every pair is 101. Now, how many pairs of numbers do I have? Well, if I've got 100 numbers, I can put them into 50 pairs. And so, in fact, I've got 50 pairs, and each pair is 101. And so, the total value is 50 times 101. And that, my friends, is 5,050. So Gauss was a pretty smart dude back in the day. Okay, that actually leads us to a formula here, which is in fact exactly the same formula that Gauss discovered. If we want to find the sum, the terms of a sequence, that is, we write it Sn, we can use this formula here. Now, what is this formula? Well, it's actually just the thing that Gauss did. You add term 1 and the last term, term n, together, like the 100 plus the 1, which gives us 101. And then you multiply by, well, this term, n over 2. Well, n, if there are n terms divided by 2, that's how many pairs of terms there are. So, in fact, this is going to give us the exact same result. So let's just fill in the blanks here. This is our formula, Sn, where Sn is the sum of n terms of a sequence. So it's the sum of the first n terms of a sequence. N is the number of the terms being added. Oops, I got a better pen here. Either that or just better penmanship in general. I'll zoom in a little, that might help. T1 is the first term. Oh, there, that's better now that I zoomed in, eh? And Tn is the final of the terms, or the last of the terms, I should say. Sorry to make you rewrite that, kids. All right. Now there's an alternative formula here, and briefly, we can replace Tn with this expression here from the previous video. Tn is exactly equal to T1 plus n minus 1 times d. Okay, this is something that we've seen before in section 1.1. If we take our original formula for Sn and replace Tn with this, we actually end up with this alternate version of the formula. The reason why you want this second version of the formula is this will give us the sum of the n terms if you know n, T1, and d, but if you don't necessarily know Tn. Right? Okay, let's do some examples here. First thing here I want you to do is use the formula that you have in order to answer the question, what is the sum of all these terms? Okay, I'd like you to try doing questions A, B, and C now, and see how you do, and then I'm going to take them up momentarily. So please pause the video now. Okay, welcome back from that. During the pause, you may have heard my cat Stitch meowing in the background. She likes to do that every so often. Okay, so question A, 2 plus 5 plus 8 plus 11 plus 14. Now, I mean, obviously, we could just sit there and add them all up. But we might as well use the formulas that are available to us. So we do have a formula that Sn is equal to n over 2 times T1 plus Tn, again from Gauss. We know n is 5, there are 5 terms. We know T1 is 2, and we know that Tn is 14, right? So it's just a matter of plugging all those in, so we end up with Sn equals 5 over 2 times 2 plus 14. And, boy, I hope I do this right in my head here. I get 40 for the final answer. Okay? For the next question, we've got a bit of a problem, right? I mean, you don't see all the terms. You get this kind of dot, dot, dot dealio happening. So how many terms are there? Well, with quick inspection, we can see that, well, if I'm counting 1, 2, 3, I'm counting by ones, right? So it'll be 1, 2, 3, 4, 5, 6, and so on, all the way up to 50 and 51. So there's in fact 51 terms. My T1 is 1, and my Tn is 51. So now I could figure out Sn, again using the formula above, so I won't rewrite it this time. It's going to be 51 over 2 times 1 plus 51. Okay, let's see if I can do this correct. That'll give me 26 times 51, which is some amount that I have no idea off the top of my head. Oh well, you can multiply it yourself for fun. Last one. 6 plus 10 plus 14, dot, 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 all the way to 50. Now this dot, dot, dot is going to give us a little bit more trouble. How many terms are there? Well, it's not obvious, is it? Okay, well we seem to be adding how much every time. Well, we could say that the common difference is 4. But how am I going to find the number of terms? Okay. Well, one way would just be to sort of just do it by, thinking about it. How many 4s do I need to add from 6 to get to 50? Well, you might count that out and you'd actually discover it's 11. But maybe we could find a more systematic way of doing it. We know that term n can be found by taking term 1 and adding n minus 1 common differences. Okay, this is a formula that we've seen before. Now I can plug in here to find n. I know that I've arrived at term n 50 by taking my first term 6, adding n minus 1 common differences, and each of those common differences is 4. Okay, we can now isolate n in this equation. I'll subtract 6 from both sides, which gives me 44 equals 4n minus 4. There I get 4n minus 4. I multiplied 4 times n minus 1. Okay, now I'm going to add 4 to both sides. That gives me 48 equals 4n. And so now n is 12. Knowing that n is 12, that t1 is over here at 6, that tn is 50, I can now plug my formula for the sum. And so that is n over 2 times t1 plus tn. Okay? And that will give me 6 times 56. And 6 times 56 is 336. I hope. Okay, let's go on to the next page. Okay, on this page you have 3 questions which you should be able to do now, although the first one I find a little bit challenging. And you should be able to get these with the knowledge that you have till now. I'm going to ask you to pause the video, and in a moment here I'm going to have a written out complete answer for all of these questions. So pause the video now. Okay, welcome back. Here are the answers. I'm zooming right in. Okay, in the first question here, I have a problem. First, in the first step, I don't know n. Oh no. So I can't find n, how many terms are there, by doing a little bit of backwards work in the same way that we did last time. And you can pause it to see the details, but I end up arriving at n equals 60. Once I know that, I can then do the second thing, which is plug the formula for Sn. And I end up with S60 is 7,440. Quick notation, when I say S60, I mean the sum of the first 60 terms. Okay, next question. Well, this time we've got a problem. I can't keep using the same formula that I've been using the whole time. We don't know Tn. So I can't use that same formula that we've been using all this time. That's the nice simple one, like the one that Gauss used. So first option here is that I could say to myself, okay, I'll just use Sn equals, well, that whole mess, n over 2 times 2t1 plus n minus 1 times d. Okay, well, I know all those things, n, t1, and d, and I just plug the formula, and it gives me a total of S20 equals 630. There is an alternative here that I list, is I could just find Tn first. I'm going to let you try that. If you could find Tn first, you could then use the simpler formula for finding Sn. Okay, in the last one on the page, I actually decided to find Tn to start off with. Okay, and so that we have a formula here that comes in from before, that Tn is equal to the first term plus n minus 1 common differences. Well, our common difference is 1.2. Our first term is also 1.2, and our number of terms is 15. And so by plugging that formula in, I end up finding that the final term, the 15th term, is in fact 18. Okay, so now if I want to find the sum of the first 15 terms, I can use this much simpler version of the formula where I have n, t1, and tn. Okay, and I plug all those in and I end up discovering that S15 is 144. Okay, on the next page we have a great problem because it's one that's easy to state but really tough to do. And so it takes a lot of kind of understanding, and it'll actually use, surprisingly, some stuff we learned last year when it comes to systems of equations. Okay, so let's read the problem. If the sum of the first 2 terms of a series is 13, and the sum of the first 4 terms is 46, find the 6th term in the sequence and the sum of the first 6 terms. So essentially, we were given 2 clues about this sequence or series, and, well, we want to find something else about it. Okay, so we just really need to establish what is the pattern for the series. Okay, so the 2 facts we know is that the sum of the first 2 terms is 13, and the sum of the first 4 terms is 46. Okay, that's pretty straightforward. We also have a formula, by the way, for the n sums. The sum of the first n terms is exactly equal to n over 2 times t1 plus, 2t1 plus n minus 1 times d, and then close that big bracket. Ooh, that's a big formula. We're going to use this, okay? Because when I say that the sum of the first 2 terms is 13, in this case, I will know n and I will know the sum. So I can replace those in the formula. So I could say that 13 is equal to 2 over 2, n over 2, right? Times, open bracket, 2 times t1 plus n minus 1, that's just 1, times d, which is unknown. So we don't know t1 and we don't know d. I'll just simplify this a little bit. That just says 13 equals 2 t1 plus d. Okay. We can likewise do the same on the other formula. I'll do that one in red now. I could say that 46 is equal to 4 over 2 times 2 t1 plus 4 minus 1. So that's 3 times d. Okay, I could simplify this side as well. And this would be 46 is equal to 4 t1 plus 6d. Okay. I now actually have one formula and 2. I've got actually 2 equations with 2 unknowns. This is a system of equations. Whew. Okay, so this is going to require a little bit of work from us. Okay. I'm going to write out the system here and see if we can solve it. Again, I have in blue that 13 is equal to 2t1 plus d. And my equation in red said that 46 is equal to what did it say? 4t1 plus 60. Okay, so we'll write that in. 4t1 plus 6d. Okay, I'm going to alter these equations to solve them now. I'm going to leave the first equation as is. I'll just rewrite it. 13 equals 2t1 plus d. But for the second equation, I'm going to divide both sides of the equation by 2. Well, let's see what happens. I get 23 equals 2t1 plus 3d. By dividing by 2, what I've done is establish in both equations 2t1. That's helpful. If I now subtract the top equation, or subtract the second equation from the first equation, let's see what happens. 13 minus 23 is negative 10. 2t1 minus 2t1. Oh, that cancels out. In fact, we have a word for that. It's eliminated. That process is called elimination. And finally, I have d minus 3d, which gives me negative 2d. Aha! As a result, I can divide by negative 2, and I can say that d is 5. Wow! That's wonderful. Now that I know that d is 5, well, I can work from here, and I could say then that 13 is equal to 2 times t1 plus 5, which is d, and
subtracting 5 from both sides, I get 8 is equal to 2 times t1, and therefore t1, the first term, is 4. Wow. Okay, we've got some serious conclusions that we can reach now. In fact, why don't we just write it all out, what we know? We know that the first term is 4. What's the next term? What's 9? Right, because our d, our common difference, is 5. Our next term is add 5, 14. Our next term, add 5, you get 19. Our next term, add 5, you get 24. Our next term, you add 5, and so on. So now if I wanted to answer the question, it's actually pretty straightforward. The question asks, find the sixth term. Oh, that's right there. That's 1, 2, 3, 4, 5, 6. 29 is the sixth term. And it asks for the sum of the first 6 terms. And well, we could just add up all 6 of those numbers. Why don't you do that on your own? That seems like enough of that question for now. Okay, just zooming out here real quick, I'm going to show you that there's this question here, and there's another question on the other side that are excellent word problems. Your homework right now is to complete these 2 problems and bring them to class so that we can take a look at them together. Okay? And finally, on the back page, please note that we have homework listed here, and of course time will be provided to you to get that work done. Okay, I hope you enjoyed the arithmetic series video. It was fun for me. Bye for now.